Hello friends, let us now learn some important points about the three topics in this chapter, that is in this lesson, that is saturation voltage, Heal effect and tube shielding. So first let us learn about the saturation voltage. So when this is the X-ray tube which we have dealt in the last class. This is the cathode. Cathode has a tungsten filament and the focusing cup. This is the anode with anode stem made up of molybdenum and induction motor, and these are stator coils. So when an electron from the cathode reaches the anode, X-rays are produced. So for the electrons to reach the anode, there is filament. When this filament, electricity is passed through the filament, that is when this filament is heated. When this filament is heated, the electron which is present in the atom of the outermost electron, it will move outside its orbit for a certain distance. And when lots of electrons move outside their orbits, that is, they move a small distance away from nearer to the filament. This is called as space charge effect. Actually, this is called as electron cloud. Okay, when a few amount of electron or few electrons reach the filament, reach a little in front of the filament, that is called as electron cloud. This electron cloud will prevent the further electrons to overcome the electrons cannot reach the anode. So for the electrons to reach the anode, it needs to have sufficient energy and sufficient velocity to overcome this electron cloud. Okay, so that the space charge effect is the ability of this electron cloud to prevent an electron to travel towards the anode. Okay, so if we increase, so first we have increased the kVp. So first kVp is 0, there's no flow of electrons at all. Slowly when we increase the kVp, one electron will gain momentum or will gain energy to overcome this electron cloud, and it will bombard or it will travel towards the anode. It will accelerate towards the anode and it will hit the anode. So one electron will overcome the electron cloud or overcome the space charge effect, and it reaches the anode. So when we increase the kilovoltage peak, the more electrons, as we increase the kilovolt peak, that is, as the voltage is increased, more electrons gain energy to overcome the space charge effect and to hit the anode. So as a result, more electrons meaning more tube current. So as we increase the kilovolt peak, the tube current also increases. Once it has reached a saturation voltage, which is called as 40 kilovolt peak. So at this 40 kilovolt peak, the space charge effect has no effect, because almost all the electrons have gained energy which is required for the electrons to reach the anode, to accelerate towards the anode. So as a result, at saturation voltage, the space charge effect has no role. So what has role? That is the filament. If more electrons are produced by the X-ray filament, then they are accelerated towards the anode. So that means the filament is mainly limited by the temperature. So after 40 kilovoltage peak, it is almost more or less same. That is, there is very little change in the tube current if we increase the kilovolt peak. Thus, it is emission limited or temperature limited. So to sum up, at 40 kilovolt peak is called as saturation voltage. Below the saturation voltage, that is 40 kilovolt peak, there is increase in kilovoltage peak. Has the tube current increase, has the kilovoltage peak is increased, there is increase in tube current. As we increase the kilovolt peak or voltage, then the tube current increases. After 40 kilovoltage peak, that is after saturation voltage, though we increase the kilovolt peak, there is only very small difference between the tube current, and this is limited by the temperature of the filament. That is saturation voltage. Then the next important thing is about the Heal effect. So what is Heal effect? Heal effect is when the electrons, so this is the filament, so when electrons hit the anode, anode will release X-rays. The X-rays are released in these different directions. Or not all X-rays will go in perpendicular. The X-rays will go in different directions. Okay. Few X-rays are towards the anode end. So these are anode end X-rays. Few X-rays are towards the cathode end. So this is cathode end X-rays. So if we see the intensity of X-rays, this is intensity. The intensity of X-rays along the anode end is lesser, here 31, when compared to the intensity of X-rays at cathode end here, which is 95. So the main reason why there is difference in intensities is that when initially when this is emitted here, it has 95 intensity only. The remaining one is absorbed. Few X-ray photons are absorbed by the anode itself. See, anode is negative. So when the electron hits the anode, few of the X-rays which are produced at the anode end are absorbed by the anode itself. Because few of the X-rays are absorbed at the anode, by the anode at the anode end. At the anode end, the intensity of X-rays is less when compared to the intensity of X-rays at the cathode end. So this depends upon the angle of emission. So if the angle of emission, so this is the angle of emission. If this is the X-ray, this is the angle with which the X-ray is toward to the anode. The angle of the X-ray at the anode is called as angle of emission. So this is called as angle of emission. That is the angle between the X-ray photon and the anode, angle of emission. This intensity depends upon the angle of emission. If the angle of emission is less, that is if the X-ray is nearer to the anode, then the intensity is less. If the X-ray is away from the anode, that is the angle of emission is more. So that means the X-ray intensity is also more. So next there are two important things which will determine the Heal effect. One, the film size. Second, the film to focus to film distance. One, film size. Second, focus to film distance. So if we use smaller films or larger films, so think that this is the larger film. This larger film, at the anode end, the intensity is 85. At the cathode end, the intensity is 103. So there is difference of around 15 to 20 difference is present for this red film, whereas for this orange film, which is a smaller film, this will have a distance difference of very less. So it is some 90s and this is around 102. So there is only 10 variation in intensity of X-ray for a smaller film. So if we use smaller film, the Heal effect decreases. So when compared to larger films, if a smaller film is used, then this will decrease the Heal effect. Then second parameter which affects Heal effect, which determines Heal effect, is focus film distance. So the distance between the anode, that is focus, to the film. If the focus film distance for this film is 40 inches, the second film it is around 72 inches. As the focus film distance increases, so if we see this difference here at the anode end, for this film at the anode end, the intensity is 73, and at the cathode end, the intensity is 105. So it is around 30 intensity difference is present between the anode and cathode end for this film. Whereas for the second film, the difference between the anode and cathode end is around 15. So as we increase the distance, the Heal effect decreases. That is the difference between the anode and cathode, and difference between the intensities of X-rays at anode and cathode end decreases. So that means Heal effect decreases. So at the end of the day, you should remember that the Heal effect decreases when we use smaller films and when we use larger focus to film distance. So is this Heal effect useful to us or not? So we have found a good use for this Heal effect. The main use is of so if you see in the Heal effect at the anode end, because some of the X-rays are absorbed by the anode, so at the anode end the intensity is less, whereas at the cathode end the intensity is more. So as a result, we can use it to our advantage. So if you see our body, the upper thorax will be thinner, whereas the lower thorax will be thicker. Okay, upper thorax will be less thick, whereas lower thorax will be more thicker. So as a result, upper thorax can be placed at the anode end, whereas lower thorax can be placed at the cathode end. If upper thorax is placed at the anode end, it will receive less intensity X-rays, which is sufficient for the upper thorax. Whereas if the lower thorax is placed at the cathode end, it will receive more intensity of X-rays. So as a result, this will even out the film, and it will also decrease the amount of X-rays or radiation to the patient also. So the thinner part of our body is placed towards the anode end, and the thicker part of our body is placed towards the cathode end. By this way, we can decrease the radiation to the patient, and this is called as Heal effect. Then the third topic for this today is tube shielding and high voltage cables. So before we go into tube shielding, one thing which you have to see is that when the filament is heated, electrons are produced and they hit the target anode. When they hit the target anode, till now we have been drawing the electrons are produced in this direction. Sorry, the X-rays are produced in this direction. Very good. If the electrons directly hit the target anode, they will have the X-rays are produced in this direction. So majority of X-rays are produced in this direction, but few X-rays might be produced in other directions also. Few X-rays might reach the tube and they may get scattered. Few X-rays may reach the tube, X-ray tube, and they might get scattered. Or few of the electrons might bombard the tube and they might also get scattered. So the X-rays, majority of X-rays are towards the patient. Okay, 90% of X-rays will be towards the patient, but few X-rays will also be scattered in all directions. So these scattered X-rays will be our problem. So when the X-rays are scattered, so these will increase the radiation to the patient along, because see, this is the wanted X-ray, needed X-ray which will hit the patient, which is good. See, this is not the needed X-ray. So this is the X-ray which is not, which is unwanted. So as a result, when it hits the patient, this is the excess radiation hitting the patient. So there is increased risk of radiation to the patient and also to the technician also. If the technician stands outside the tubings, then obviously this can come, this X-ray can come and hit the technician. So as a result, there is high intensity of radiation around the X-ray tube, which is a problem to the patient and also to the technician. Second, there is increased exposure to the patient. We have already seen. Third, there is fogging of the film, because if this unwanted radiation falls onto the film, there is fogging at the film. So this unwanted radiation which is scattered in all directions is called as leakage radiation. So this leakage radiation, there is a limit how much the leakage radiation should be there. So that there is something called as National Council of Radiation Protection and Measurement. According to the National Council of Radiation Protection and Measurement report number 49, the leakage radiation measured at distance of 1 meter from the source, if this is the source, at a distance of 1 meter from the source, the leakage radiation should not be more than 100 milliroentgen in 1 hour. It should not be more than 100 milliroentgen per hour. Try that. It should not be more than 100 milliroentgen per hour if the tube is operated at maximum continuous rated current at maximum rated potential. So how will we prevent this leakage radiation? This leakage radiation is prevented by tube housing. So it is a big lead container. So this X-ray tube is placed in a lead container. So this lead container is called as tube housing. So this tube housing is nothing but is made up of lead, and which has this X-ray tube. The space between the X-ray tube and the tube housing lead is filled with oil. So this oil is a good thermal insulator, and also it has good cooling properties. So as a result, so it is a good electrical insulator and it will have good thermal cooling properties. So as a result, oil allows usage of good complex X-ray tubes, and oil is very important to dissipate the heat from the X-ray tube to outside, and it will also block all the leakage radiation. So one important thing is that we have to make sure that the space between the X-ray tube and the tube housing is filled with oil only. There should not be any air inside the tube housing. If there is any air inside the tube housing, the air will expand on heat and it will rupture the tube housing. So if there is any air, that air will expand on heating and it will rupture the tube housing. So we should make sure that there is no air inside the tube housing. Next, one more important thing is that the tube housing is grounded. That is, placed to the, it is attached to the ground or to the earth. Then, one more important thing is when the X-ray tube is heated, the oil also gets heated. When the oil gets heated, there are something called as metal bellows in the tube housing. So these metal bellows, when the pressure inside the tube housing increases, these metal bellows will trigger switch, and this switch will be switched off. So as a result, this will prevent the expansion of oil and it will also prevent the further exposures. It will prevent the further exposures of X-rays. So these are the important points about tube housing, saturation voltage and Heal effect. Thank you.